Hello everyone. Today I am going to present about torsion testing. Torsion testing is used to determine the shear properties of materials. In this test, a specimen is subjected to twisting force called torque. The test is very important in mechanical and structural engineering. Introduction to torsion. So, about definition, torsion occurs when a structural member is twisted about its longitudinal axis by an applied torque. Torsion means twisting of a member due to applied torque. When torque is applied, shear stress develops inside the material. The stress is zero at the center and the maximum at the outer surface. The material experiences angular deformation, which we call as angle of twist. Within the elastic limit, torque is proportional to angle of the twist. So the linear relationship helps us to calculate the modulus of rigidity. And about objective, determine the mechanical properties of material subjected to shear stress. And some common applications are drive shafts, axles, drill bits, and helical springs. And the drive shafts is about it's a circular rod which we use to assess specimen in the testing. And helical springs also similar to drive shafts. Drive shafts is a circular rod, but here helical spring is like a spring-like structure. And when we comes to working principle, imagine holding a metal rod firmly at one end and twisting the other end. What happens? The rod starts to rotate and experience shear stress inside it. That is exactly what we do in torsion testing machine. First, we fix the specimen between the two grips of the machine. One end is kept fixed and the other end is rotated slowly. As we rotate it, torque is applied to the specimen because of this torque. Shear stress develops inside the material, that is the center of the material. The material undergoes angular deformation when it twists. That is in the diagram we can notice that this is the line. The actual line, when we twist, the line is going to this upwards. So the angle between these two region is called as angular deformation, and here shear strain is produced. The machine, we can remove this. The machine measures two main things: the applied torque and the angle of twist. The angle of twist is that I mentioned before. Using these values, we calculate shear stress, shear strain, and modulus of rigidity. The torque is nothing about with the specimen in the machine, number of rotations it takes to rotate. Torque is measure how much a force acting on the object causes that object to rotate. The object rotates about an axis which we will call the pivot point, and will be able. A torque is nothing a twisting moment applied to a material specimen, including rotational twist and shear stress. In image we can see that L is the length of the specimen and theta is the angular deformation occurs to the specimen. And let's go to this is torsion specimen. Now we go into torsion specimen. It is usually in cylindrical, uniform in diameter, longer compared to its diameter. We prefer always circular cross section because when we apply torque, the shear stress distribution becomes uniform and predictable. And also circular sections don't warp easily under twisting. So we usually select the circular rod for torsion testing. And key formulas and theories are T by J equal to tau by R equal to G theta by L. Here T is the torque that we see before, and R is radius of the wait a minute radius of the rod, uh, and J is the polar moment of inertia. Angle of this theta equal to, that is I mentioned here. These equations derived from torsion theory and we very important for exams. And when we comes in point of view test procedures, measure diameter length of the specimen, fix the specimen properly, apply torque gradually by rotating that machine, and continue until it fracture, and note down the torque, and it is usually in tropometer. From the readings, we calculate shear stress and modulus of rigidity. It is similar to the stress strain curve. Here we see about torque versus angle of twist. When we clearly see this image, we can able to tell that this is the yield point, here where the material becomes permanent deformation begins, and this is elastic region, and this are deformation begins, and at this point fracture occurs. Fracture is nothing the point where the specimen snaps, break, that is breaking of the material. So some properties determined. Modulus of rigidity indicates the stiffness of the material and shear yield strength. The stress at which the material starts to deform plastically. Modulus of rupture in torsion, the maximum shear stress the material can withstand before failing. Ductility, measured by the total angle of twist at the point of failure. And these are failure modes, that is a ductile torsion, brittle torsion failure. So among ductile materials, fail along a plane perpendicular to axis. In image we can see in ductile materials the surface of fracture is see like this, and surface of brittle is see like this. The surface is like a even, in brittle it's like a irregular shape. In brittle materials, the material fails at the 45-degree angle to the axis. This is because brittle materials are weaker in tension than shear, and maximum tension occurs at 45 degree during torsion. And some common applications are in aerospace, the propeller shaft, and in industries, turbine shafts. These are like circular in circular like rods and fasteners, bolts and screws. These are also used to test the torsion test. So by this torsion testing, we can ensure safety and reliability of rotating components. How much we can stand the torque, and when we come to conclusion, torsion testing is critical for components that transmit power. It provides unique data that cannot be accurately derived from a alone. Standard test alone. Torsion test helps determine shear strength. It is essential for design of rotating shaft, and it ensures safety in mechanical systems. Without torsion testing, many rotating components may fail. So, the torsion test is one of the important testing in mechanical material testing. Thank you.